Hexa topological spaces. They've been introduced in 2020 by Vijaya Chandra and Pushpalatha. They are natural generalization of penta topological spaces presented in 2018 by Khan and Khan. Assume that X is a non-empty set and we have 6 topologies on X. Then we say that A containing X, subset of X, is hexa open, that is age open, if it belongs to tau 1 or tau 2 or tau 3 or tau 4 or tau 5 or tau 6. Of course, its complement is called age-closed set. One thing is interesting. As we could see, Chandra and Pushpalatha assume that age-open set is the one which is open at least in one of the 6 topologies which constitute this hexa space. This is consistent with the approach presented earlier by Khan and Khan in the context of pentatopologies. Furthermore, in case of quad spaces with 4 topologies, Mukundan used the same reasoning. A is quite open if it belongs to tau 1 or tau 2 or tau 3 or tau 4. However, things are not so clear. For example, in the context of 3 topological spaces, Palanyamal in his doctoral thesis defined 3 open set in the following manner. A is 3 open if it's contained in the intersection of these 3 topologies which constitute 3 topological space. This definition was used also by Mernillo and Chaganan, who studied ideal 3 topologies, and another author who shared this opinion was Abdul Mahdi from Iraq in his Bakelor's thesis. On the other hand, there were also mathematicians who defined 3 open set analogously to these definitions from quad and penta and hexa topologies, namely as the one which belongs to the union of 3 topologies, so which is opened at least in one of them. For example, Tapi and Ranu Sharma used this definition, and the same with Hamid and Abid, or Priyadarsini and Parvati. As you can see, there is no any consensus on the definition of an open set in general. Be as it may, Chandra and Pushpalatha choose one of possible approaches, and for example, they give this example of hexa space. Well, rather a trivial one. We could say that it's something like hexa monosingleton space. A subset A of X is called H neighborhood of X, even only if there exist 8 H open set U such that X is contained in U and U is contained in A. If we have 2 hexa topological spaces, then a function from X into Y is called a hexa continuous if pre-image of V is H open for every H open set V in Y. Pre-image is open in X, of course. It's called H continuous at a point X if for every H open set V containing f of X in Y there exists an H open set U containing X such that f of U is contained in V. And they say that these definitions are equivalent on the ground of hexa topological spaces. As we can see, these definitions are rather typical. The authors defined also HB open sets, and HB open set is defined just in typical topological spaces, namely in this manner. Of course, hexa closure and hexa interior are defined as respectively intersection and union of closed sets in which A is contained, or open sets which are contained in A. Well, these are some papers about 3, quad, penta, and also hexa topological spaces. As for the hexa spaces, we saw that there is a paper by a guy named Shihab about hexa homeomorphisms, perhaps, but it's not available. The link is broken. Be as it may, here you have some literature about these spaces. Thank you very much for your attention.